kinematics of a rigid body, kinematics of a multiple rigid interconnected multiple rigid body. Once you solve the kinematics, then you have to solve the kinetics, which is also sometimes called as the dynamics. Now, as you know, the objective of the kinematics to study the geometry, motion characteristics, and the time interrelationship between these three quantities is the objective of your kinematics, where we will not consider the cause of motion. But once you find out the for a given input what will be the output motion characteristics, then next question will be in order to get the dz motion characteristics, what could be the input force or input torque? So that has to be solved in kinetics. So objective of the kinetics is to find out how much force or how much torque is required to get the dz motion characteristics of any links. So here you have to consider in kinetics, you have to consider the external force or external torque applied. That depends on the joint. If it is a rotary joint, then torque. If it is a prismatic joint, then it will be the force. Along with the inertia has to become the picture. So inertia force will also you have to consider in case of a kinetics. And in order to get the desired motion characteristics, how much external force is required once you find out, then you have to check whether that force can be withstood by individual component or not. And for that, internal effect analysis of a body is important, and that has been covered in a strength of material class where you will carry out the stress analysis, deflection analysis, and so on. Ultimately, you will design a mechanism or a machine. Now, aim I already mentioned. The aim of the kinematic analysis to establish the relationship between the motion of the various components or the links or the elements of a mechanism. An objective is to determine the kinematic quantities. So, kinematic quantities or kinematic parameters are position, the most fundamental one, displacement, velocity. That means time derivative of displacement is velocity and time derivative of velocity is acceleration. In some cases, time derivative of acceleration jerk has to be considered. So these are the kinematic parameters or kinematic quantities. So objective is to determine these kinematic quantities of the links or the elements in a mechanism when the input motion is given. For example, a slider crank mechanism, if it is used in the IC engine, then input side is the slider side where you have to apply the gas pressure by burning your fuel. So that will be the input. And what you have to find out, what should be the RPM? What should be the RPM of the crank and from crank to crankshaft? So that is one objective. Or in the reverse way, in order to get the DZ input, in order to get the DZ input motion, or sorry, in order to get the DZ output motion, what could be the input required? So to determine the input motion required to produce the DZ or specified motion of the another link or output link. Same example, like in IC engine, suppose I have to run my vehicle of this particular speed. That means I need the crank RPM is this much. And in order to get that, what could be the input motion? That means what could be the slider velocity? And accordingly, the fuel will burn. So either objective is to determine the kinematic parameter of the different link, including the output link for a given input, or is to determine the reverse problem, to determine the input motion required to produce the desired output motion of desired output motion or desired motion or specified motion of other links, including the output links. Now, in the steps involved in the kinematic analysis of plane mechanism or special, whatever may be the case, first, once you know the kinematic parameters, configuration of the mechanism and kinematics parameters or kinematic dimension is known to you, then you have to draw the space diagram and you have to carry out the position analysis and thereby the displacement analysis. Once you got the displacement equation, time derivative of that one will be the velocity equation, and that way you can carry out the velocity analysis. Again, time derivative of the velocity will be your acceleration, and that way you can carry out the acceleration analysis. And I've also explained what is the kinematic dimension. For kinematic analysis, first what you have to do, you have to draw the kinematic diagram. And kinematic diagram, the important thing is the node to node distance, because for kinematic analysis point of view, the other dimension like the geometry, width, or all these intricacies of the geometry is not required. That I have already explained here. In case of your slider crank mechanism, that actual slider crank mechanism which is used in the IC engine looks like this one, but it's a kinematic diagram representing by the kinematic notations where node to node distance important. If it's binary link, so this center motion, the center of the motion axis, and from to the center of the another motion axis of a link is basically node to node distance, and that dimension is known as kinematic dimensions in case of a binary link. So node to node distance or the joint center to joint center distance is basically known as kinematic dimension, and that dimension is sufficient for kinematic analysis. But in order to do the kinetic analysis, that time mass property will come into the picture, inertia property will come into the picture, that time actual geometry and the mass of the component will be more important, and that is why that time only kinematic dimension is not sufficient. But for kinematic analysis, mass property, inertia property is not required, and that is why node to node distance is sufficient to carry out the kinematic analysis, and that is why we will draw the kinematic diagram first. Now the method used for the kinematic analysis of the plane mechanism are classified into two groups, or broadly classified in two groups. One is the graphical method, another one is your analytical method. Now, graphical method, though this graphical method provides better insight and visualization of the problem, but accuracy of the solution provided by this method is often limited, because in graphical method, if you use your set square, drafter, and then human error will be there. And if you use the software like AutoCAD or any other graphics tool, then you will get more accurate result. But graphical method is a tedious job, because each particular instant, each particular configuration, you have to draw the space diagram, velocity diagram, and acceleration diagram. Now, if you take the, for a complete rotation of a crank, if you divide that complete rotation of the crank into the, say, 2000 instances, then 2000 times you have to carry out the space analysis, the space diagram, velocity diagram, and the acceleration diagram. And it's a truly tedious job. It's basically too tedious, so it will not practical for getting the time history of the kinematic parameters. But it will give, if you for a particular time instant, if you carry out, it will give the better insight of the problem. And so that is why, in order to clear the fundamentals, you have to use, you have to learn graphical methods. It may be the relative velocity method or instantaneous center method. These two methods you will learn. And I think Professor Bera will take these two things. I will more prefer the analytical methods, the vector approach by loop closure equation, or the algebraic approach by projection method. Now, there is certain advantage of the analytical method, and that is why analytical method is preferred over the graphical method, because by analytical method, a high level of accuracy is possible. When you need a high level of accuracy in your calculation, better to go for analytical method. And analysis has to be carried out, when analysis has to be carried out for a large number of configuration, because in order to get the time history of the displacement, velocity, and acceleration, that means for one complete rotation of the crank, what could be the motions of the other links? That means if you like to plot along x-axis is the time for one complete cycle, and the y-axis is your displacement or velocity or acceleration of the other link. If you like to plot, that means you have to solve the number of time instances that particular velocity acceleration you have to evaluate, and then you can plot it. So if you do this in graphical method, it is a tedious job. Instead of that, if you use the analytical method, then same equation is valid for all time instant. Only you change the time instant, you will get the solution. So that is why analytical method will be more easier, and because of that, analytical method are being widely used in computer implementation. That means computer aided engineering tools, that means computer aided design and engineering tools like your Adams, your CATIA, NX, your SolidWorks, all are now using the analytical method for solving the kinematics. So the advent of the computer and high-speed computer, the analytical method becomes more popular and more practical than the graphical methods. And for that reason, we like to here learn the analytical method, because industries are using the analytical method. Graphical method for beginners to get the insight of the problem. But once you know you understood the particular things, the concept of the vector, velocity, and acceleration, then by analytical method, you have to solve problem because of this advantage, and industry are using the analytical method. Now, for analytical method or even for the graphical method, first step is to draw the kinematic diagram that I mentioned, and for that these are the convention you can use. Different book use the different convention. So whatever diagram you like to draw now onwards, that is not the actual diagram of the mechanism. Rather, it is called the kinematic diagram of the given mechanism. So I already mentioned, as a result of the assumption of rigidity, many of the intricate details of the actual part shape or part geometry are irrelevant when you like to study the kinematics of a mechanism. And for this reason, it is common practice to draw highly simplified schematic diagrams which contain important feature of the shape of each link, such as relative location of the pair element, but which completely subdue the real geometry of the manufactured part. But the simplified schematic diagram will serve your purpose for kinematic analysis for a particular time instant. And that is why this simplified or the schematic diagram is known as kinematic diagram. And such diagram depicts the essential kinematic feature of the mechanism. And these are the symbol used, or convention used to represent a mechanism, or in order to draw the kinematic diagram of a mechanism. Now here we like to use the analytical method I already mentioned, and more specifically I like to tell you here the vector approach. So I still believe, because all the softwares, all the tools, automation tools are basically based on the vector approach. So it's my I also believe that you should also learn vector approach. You learn mechanics as a vector mechanics, not like a scalar mechanics which is used in the Timoshenko and Young book. So rather, the engineering mechanics, or more specifically in the name of vector mechanics, you should learn that vector mechanics written by the vector. I don't know exact name. The engineering mechanics or vector mechanics, something engineering mechanics in vector approach by Baron Johnston, or the book of Mary and Craig or something like that. Mariam Craig. So this kind of book where the vector approach has been used, same concept we like to use here. So in vector approach, the most simple thing I like to represent this, the convention we like to use in this particular class, because if you follow a book, different book use the different convention, but all are correct. But before going through the actual analysis, please check your convention if you like to follow the book. The convention I like to follow here is like this. First, you have to understand the Cartesian, right-hand Cartesian coordinate system. Though it is the planar case, so we will treat in a plane x and y to perpendicular Cartesian coordinate or the perpendicular axis. But in 3D case, you have to consider the z also. So here we'll use the right-hand Cartesian coordinate system. Say so, as I've shown, this is the x-axis. Along x-axis, unit vector is I cap. Along y-axis, unit vector is the j cap. And now you just see that any point P, its position vector is represented by the. I like to show you here that this is O. So OP. So position vector is OP. So position vector will be your OP vector. So just here as a bar represent the vector. That means it is the RP vector. Symbolically, I am writing R suffix P. R suffix P vector. Now in this vector, you just see this is the tail and this is the head end. And we like to measure, the vector having magnitude as well as the direction. Now, the direction has been measured with respect to the positive direction of the x-axis, anti-clockwise positive, and at the tail end. The convention I like to use here that we'll measure the angle of the vector, the direction of the vector with respect to the positive direction of the x or any axis parallel to x at the tail end. That means this is the tail end. The tail end I like to measure with respect to the positive direction of the x-axis or parallel to that, and anti-clockwise direction will move, and then that angle will be the positive angle, treat as a positive angle plus that value theta p. Now as you know that the vector rp equals to here, then it's rp and its magnitude of vector rp. Here you just write the absolute value of the vector rp is simply I am writing as a r of p. So no bar. That means here rp the scalar quantity, the magnitude of the length of the vector rp. Now that means the magnitude of this vector is the rp. So let us and its x component will be obviously the rp cos theta, and y component will be your rp sin theta p. So rp cos theta p dot product I cap plus rp sin theta p j cap. So this is the vector representation. So mod value equal to root over of the x component square plus y component square, and that has been mentioned here. Now I like to show you that if as you know in the Cartesian coordinate, the first coordinate, second, third, fourth. Now if your vector is lying like this is OP, again this is the OP vector. Now how will write here, as I mentioned, the tail end is this one. This is the tail end. In this tail end you have to measure this angle. With respect to which reference you'll measure the angle? Positive x direction. This is the positive x direction. With respect to that, which direction will move? Anti-clockwise direction I will move. So this will be your theta p. Similarly here, when a in vector is lying in OP vector lying in a fourth quadrant, you can measure this way also, but at the tail end is this one. You look here, this is the tail end. Here my positive direction of x-axis is this one. With respect to I measure and I will move anti-clockwise direction, like this is anti-clockwise direction, positive, this is theta p. You can also move in the opposite direction also in the acute angle you will get. So that value will be minus and certain angle, that is theta p prime. That way also you can write, you can do theta p prime, another value is the negative value, because if you like to move in a clockwise direction, then as per the right hand rule, its value is negative. So with this fundamental vector concept, we like to move how we will use this concept in the mechanism analysis. So here a few more convenient notation of the position vector I like to mention, because if you follow the different books use the different notation. So in order to avoid any further confusion afterward, because I suggest you to follow book, but it is your preference which book you will follow. But different book use different notation. You should not be confused on that, and that is why I just jot down here that this is the way they represent. All are basically representing the same vector. So the RP vector, if you represent in a Cartesian form that I just mentioned in the just previous slide, is this one. That vector, if you write in a polar form, so as you know from your mathematics class, it is written as R of P, this is angle sine theta P. So it is a symbolic representation of the polar form of representation of the same vector RP. Clear? Now the RP vector, that means I have shown here, this vector, if you can represent in a complex number representation, and as you know from your vector mechanics or something or physics class, that if you like to represent it is in a complex number representation, as you know, complex number representation, your x direction is the real axis and y direction is the imaginary axis. That means x component will called as a real portion of the complex number, and y component is called the imaginary portion of the real number. So that means if you can represent it is in a complex number notation, then the same vector here you could draw. So along, this is the imaginary axis, this is sorry, this is the real axis, and this is the imaginary axis. Same vector here OP, then component, that this component is your real part. So that means RP cos theta P, real part, because the vector I am representing, same vector RP in a complex number representation, I am representing as a RP cos theta P plus J RP sin theta P. Here J is not J cap, the J equal to root over of -1. So that I have shown here. Complex number algebra, if you can use, then when you complex polar algebra, you can use this will be the notation. So the RP e to the power j theta p from your mathematics you might know, and you expand it, it will be the RP cos theta p plus j RP sin theta p, where j is the unit of imaginary number root over of -1. Now you know from your well-known Euler equation from the trigonometry, e to the power j theta p, e to the power j theta p, where j equal to root over -1 equals to cos theta p plus j sin theta p. And if it is so, e to the power j theta p, with that rp you multiplied, then you will get rp cos theta p plus j into the rp sin theta p. So that means this will be your same vector you represent in a complex number representation, you will get this one. Now you just see, this will be the real part of the complex number. This is the real part of the portion of the complex number, and this portion is called the imaginary portion of the complex number. Now what does it mean? You have seen here that this is the x component of the vector, the scalar component is the x component, and this one is the y component. The same thing here, real part will be represent the x component, and the imaginary portion is represent the y component of the your position vector. So different book use the different notation, either Cartesian form or the complex number representation in polar form or in a polar complex form. So this is called the complex polar form actually. This also representation, the expanded, either it will be, you can represent by this way or this way, both are correct. It is represented by this one, and this complex number represent ultimately the component. When you take the x component and y components remain same. So these are the different notation used in the different books, nothing else. We like to follow, or I like to follow now, is the first one. So I like to do first one, this one. Afterward, we'll use this one because both are same actually. So we first will use the traditional way, you know, that the Cartesian form. Now up to this, do you have any doubt? Anybody have any doubt?
No, sir.
No, sir.
So next is your the position analysis or displacement analysis of 4R linkages. Now 4R linkages means that 4-bar linkages. All 4 joints are revolute joint that you have seen many times, number of videos that this is basically 4R linkages. Now 4R linkages, this one is a ground link. So this one will be your ground link. So I just make it be, it is obvious also, it has been shown symbolically here. So this is the grounded links. This is the link number 1. Now what are the steps you have to follow? For kinematic analysis, once your mechanism is given to you or mechanism configuration is given to you, first thing you have to do is draw the kinematic diagram of the mechanism. In order to do the position analysis, very first step is to draw the position, kinematic diagram of the mechanism. And sometimes it is also called the space diagram. So once you draw this diagram, the red color I have shown, and symbolically you just draw it. If you can, circle represent the rotary joint, here circle represent the revolute joint, here revolute joint, here revolute joint, and this indicates that it is the fixed link. Okay. So once you identify that this is your fixed link, and other links are the rotary link. Now next step is to, you know that in mechanics, in your class 11 level physics, you know always you have to attach coordinate frame, because if I tell you what is your position now, then obviously next question will come, with respect to whom? If I tell you what is your position now, where are you now, or which particular location you are now, so in a particular room, then you have to tell, with respect to this I am here. So that way, when you like to define a position of a point or an object, always you have to tell with respect to reference frame. And that reference frame is, if your Newtonian frame, that means the frame of reference, then it will be the unique, it will be the general way to represent, and you should represent with respect to the your reference frame, or you first define your reference frame. So that is why first step, a second step is to attach the reference coordinate frame, that is the right hand Cartesian frame, and this should be attached on the fixed link, where in convenient location. For example, the first joint here, the first joint I like to fix this coordinate frame, and you just see I can attach coordinate from my own way. That here I have shown the x is horizontal, but I can keep x also along this particular fixed link. I can keep there also. But in order to represent in a more generalized way, here I have intentionally drawn that x is horizontal and the fixed link is slightly, it's not in line with the x-axis. You can keep it also in line, so there will be no harm. You can keep it along this axis also, along the link of the fixed, along the fixed link. X-axis is along the fixed link, but I have not drawn purposefully because I like to derive general or more generalized way. So here I kept x-axis horizontal, and obviously y-axis will be perpendicular to that, that means vertical. And along x-axis unit vector is I, along y-axis unit vector is j, means j cap, I cap and j cap. Can you hear me?
Yes, sir.
Yes, sir.
Yes, sir. Yes,
Yes,
sir.
sir.
Yes, sir.
So next step number 3, you just number properly that your link number as well as the joint number. As you know, the fixed link you treat as a link number 1, the first movable link is the link number 2, second movable link is the link number 3, and the output link is just a link number 4. So link numbering is over. Joint numbering. So this is your input joint. This is joint number 1. This is joint number 2. This is joint number 3, and this is joint number 4. So joint numbering is over. Type of joint is already know. It is all joint number 1, 2, 3, 4. All are R type. Now next step is a very important step, that is represent each link. It is a binary link. No, all links are binary links, and there are the two node points, and lining joining these two node points represent a vector. Clear? Here all links are binary link. Each binary link having two node point. Line joining these two node point. That means the center of the joint is the node point. So center to center you just join by a line that I have shown here, red color, this one, and this is represent a vector. So that means from here this particular first movable, this the first movable link from first joint to second joint, first node point to second node point, I represent by a vector. So I just draw a arrow. That means this is the your head and this one is the tail. So your next step, represent each link as a vector. Represent each link as a vector. So this is your first joint. First movable link means link number 2, and the vector is R2 vectors. This vector I'm line joining these. This is the tail end. This is the head end, and this vector is known as R2 vector. Now the third link means second movable link. The third link, this one will be your tail, and you just represent this vector. Draw the line join, and this will be your head. So this is R3 vector. Again, the fourth movable link, third movable link, that means fourth, here the fourth link from here to here, this is your tail end, and along this will be your head. Then this is the R4 vector. Now go to here, this link sequentially move from starting from here, move say this direction, a particular direction. You can move this direction also, that is your choice. I have moved like this direction, so any direction you can choose now, but you have to move this always in the same direction. Now from here, this is the tail end, link number 1 along this, and you just here, this is the R1 vector. Clear? Any doubt? Do you have any doubts?
No, sir.
No, sir. No, sir.
Next, I like to draw like one equation, or I like to bigger picture I like to show. So that I have drawn, this is the R2 vector, this is R3 vector, this is R4 vector, and this represent the R1 vector. Got it? So each link represented by a vector. We start from the input end, and we'll move the first movable link to second movable link to third movable link to the fixed link, like this way move. So in this representation, magnitude of that means the magnitude of the vector, that means length is known. You got it, because node to node distance is the length. The mod of R2 is the length of the first move link. Mod of R3 is the length of the second move link. Mod of R4 equal to the length of the third move link, or rather better to say that the mod of R2, that means node to node distance, from this node to node, this distance is basically length of the second link. Then R2 mod of R2. Mod of R3 is the node to node distance. Mod of R4, this node to node distance. Mod of R1, this node to this node distance. Now a vector is represented by its magnitude as well as the direction. Now how will measure the direction? I already mentioned you have to measure direction at the tail end. Now you just identify for the vector R2, which one is the tail end? Vector R2 tail end.
O point. O point.
So this one is the tail end, no? So I just like to change the pointer color. So this is your tail end. In this tail end, this is the positive direction of the x. About this anti-clockwise direction, you measure the angle, and this is your theta 2. Got my point? Now, for the R3 vector, tail end is this one. At tail end, you draw a line which is parallel to your the reference x-axis. So this is parallel lines I have drawn. Now that means this direction is the same as the positive x direction, localized frame attached basically. Now this will be your parallel to y direction. Now how will measure? The tail end you have to measure, and positive x with respect to the positive x direction, then that means this will be theta 3. So got my point? Similarly, in R4, this is the tail end. Here you again this particular tail point, you draw a line which is parallel to this my x-axis. So this is parallel to this one, and corresponding perpendicular to that, this will be parallel to y. So this is again localized frame. So what could be the angle? Angle of this particular vector. So if you start from the positive direction of this localized x, so you start from here, anti-clockwise direction, you move from here to here, this will be your angle, theta p, say. But if you consider, how much will be this angle? If you consider this one is theta 4 geometrically, then how much will be this angle? What will be this angle? Let us say this is theta. Instead of symbol, I like to use let us say this angle is uh, just a minute, mouse is not moving. So let us say this angle I am representing this different symbol, say theta 4 bar. Say how much will be the theta 4 bar? Use geometry and tell me.
Pi plus theta 4.
180 plus
180 plus theta 4. So 180 plus theta 4, pi plus theta 4. 180 plus theta 4 that I have shown here. But it is not, I should not measure like this way, but in the figure it has been given, that is why I have chosen this. But your angle of the vector is your theta 4 bar, whatever I mentioned, because I mentioned you have to follow a particular convention. Otherwise, it will be, you will face lot of problem. If you use this convention that where I will like to measure, then there will be no problem. Different book use different way. I can guarantee you will be the you will be in fully confused state if you will not follow a particular convention. Now your angle here, it will be the theta 4 prime, because here's angle here, you should not write this way, it should be like this way. It shows both direction you put the angle. That means angle of this line with respect to the parallel to x-axis is theta 4 here, but this is not the theta p. Theta p means that I just generalized way I mentioned, no? That rp equals to rp vector equals to rp cos theta p. Theta p is this one. Now similarly, that the only link left is the link number 1, and link number 1 tail end is this one. Tail end you draw the positive x direction, and this is corresponding y direction. Positive direction of the x is this. With respect to this, if you like to measure the angle, so angle will be this one. Clear? So let us say this one is the, instead of the theta 1, theta p is theta 1 dash, say. Now as you just see one angle, it should be double direction arrow. As this particular thing with respect to here x has been given theta 1, a angle I have shown. So what could be this particular value? Theta p value, theta p equal to 1. It is 180 plus theta 1. So
180 plus theta 1.
180 plus theta 1. Clear? Now, whatever may be the case, the thing you have to remember, I have to measure the angle of the vector at the tail end, and that tail end we draw one localized xy axis with respect to positive direction of the x. I will measure the angle, and that angle is my theta p. That theta p is the correlation with the another angle given for a particular problem. That's fine, but my here theta p is with respect to the x-axis at the tail end, positive direction of the x-axis at the tail end. That is my theta p. I mean, theta p means generalized way I am mentioning here. So theta p, the generalized way, theta p vector equals to, you already know that just a minute. So this is my theta p. So vector theta p equals to rp cos theta p I unit vector plus rp sin theta p j unit vector. Now here simple vector loop, it is all lying in a reference plane. It is the planar mechanism, no? As it is the planar mechanism, the vector representation lying in a reference plane, in the same plane. Clear? As it is lying in the same plane, and if you start from here and you just see, I like to start from here. So start from here, the R2 vector plus R3 vector plus R4 vector plus R1 vector. How much it will be? From simple vector equation, R2 vector, this R2 vector plus R3 vector plus R4 vector plus R1 vector equals to
Zero.
0.
0, because
Zero vector.
it
Zero, zero.
reaches to the same point. No, as you have
Yes,
reached,
sir.
in order to add vector one by one, as you have reached to the same point, that means its summation equals to
Zero.
Zero.
0. So
Zero.
this is called vector loop closure equation or simply loop closure equation. Either you call vector loop closure equation or simply loop closure equation. So if you understood this one, that means your kinematics is over. Whole kinematics, all the software based on only vector loop closure equations. And vector representation, you have to correct way you can represent your angles. So this is called the vector loop closure equations. Now you tell me any doubt. You don't see this one here, something handwritten thing. It will be your vector loop closure equation that you start from here, that R2 vector. So first the R2 vector plus R3 vector plus R4 vector plus R1 vector. So R2 plus R3 plus R4 plus R1 equals to 0. So this is basically known as vector loop closure equation. Now what is R2 vector? R2 vector equal to, put P equal to 2. That means if P is the index, put P equal to 2. So then it will be the R2 vector is R2 cos theta 2I plus R2 sin theta 2j. R3 vector, what will be the R3 vector? Then it will be the R3 cos theta 3I plus R3 sin theta dj. What is R4 vector? R4 vector equals to your R4 cos theta 4 bar, because you have measured here is the, you are representing this as a cos theta 4 bar, because here I have one notation used here, that is why I was in this case is cos theta bar I plus r4 sin theta 4 bar j. What will be the r1 vector? So it will be, as I written, this angle is r1 bar, so it will be the r1 cos theta 1 bar I plus r1 sin theta 1 bar j. Put this expression here. Now at a relationship you can put it relation there, because here R4 is given. It is not mandatory. I am repeatedly telling you, it is not mandatory to write here theta 4. In the figure it has been written, and most of the book also use the same way. That is why I have written. But it is not mandatory, because the two are related. No, R4 bar and theta 4 bar and theta 4 I am relating. So that is why It is up to you, but generalized way it should be this angle, cosine of this angle, sine of this angle. Similarly here, cosine of this angle and sine of this angle u. And after that, I like to show the equation. And next class, I will discuss in more details. After putting all these things that I mentioned here, the way to put this, all these things, and if you use this particular theta 4 and theta 1, then your equation will be like this. Ultimately, you can do the equation will be like this, where R2, R3, R1, R4 are the scalar length of the lanes. And if you compare the both side is the I component, that means X component. This is the X component left hand side. This will be the I component on the right hand side. I mean, this equation you just you try it in the home. Next class I will show you it. Already it is there in the slide that the part I have the negative part on the right hand side I kept, make it positive, and if you compare these two I component, you will get R2 cos theta 2 plus R3 cos theta 3, this one equals to R1 cos theta 1 plus R4 cos theta 4. Similarly, the J component, if you compare with this one with this, then you will get this equation R2 sin theta 2 plus R2 sin theta 2 plus R3 sin theta 3 equal to R1 sin theta 1 plus R4 sin theta 4. But here theta 1 and theta 4 is this two, this one and this one, not this one and this one. Okay, because I have chosen that way. So this is the scalar form of vector loop closure equation. Vector form of loop closure equation is this one. Putting this in this vector loop closure equation, putting this relations or this vector representation and separate it out the x component and y components, you will get the two scalar. So this is known as again loop closure equation in scalar form. So this is known as loop closure equation in scalar form, and this is the very important equations. One, it's basically build the relationship between your all the motion parameters. What are the motion parameters? Can anyone tell in this particular mechanism which parameter is variable and which parameter is constant? How many parameters in this equation? Here parameters are R2, R3, R1, R4. Similarly, theta 2, theta 3, theta 1 and theta 4. So total 8 parameter. Out of 8 parameter, how many parameters are constant and how many are variables?
Four are constant,
Four are
and four are
for
variable.
length of four
And
part.
four are
Okay, at a time
Is
one.
variable and
At a time one.
five are constant, sir.
five constant.
5 constant and
Three variable.
Three variable.
can anyone tell that the variable one, which are the parameters are variable?
Theta 2, theta 3 and theta 4.
Sir, theta 1,
No.
Theta 1, theta 2,
Theta 2,
theta
theta 3
3
and
and theta 4,
Theta 2, theta 3 and
theta 3 and theta 4.
theta 4 bar or theta 4 whatever may be. Okay. Theta 1 or either theta 1 or theta 1 bar prime, whatever you call, these are constant because the link number 1 is fixed link. So theta 1 or theta 1 bar, whatever may be the way you represent these, theta 1 is the constant, theta 2, theta 3 and theta 4 are variable. So out of 8 parameters, 3 parameters are variable and remaining other parameters are fixed or the constant. Clear? So two equation. How many unknowns?
3 unknowns.
Three.
3 unknowns. But two relation. These two basically relates with this will build the relationship with the motion parameters or the kinematic parameter. Here kinematic parameters are in this equation. Kinematic parameters are theta 2, theta 3 and theta 4. Other parameters are constant. Now these two equation builds the relationship between the geometry and the kinematic parameter. Which one is the geometric parameter? R2, R3, R1, R4 and theta 1 is the geometric parameter, no? Node to node distance means link length and the fixed link angle with respect to the frame. So these are the positional and the geometric information. Geometric information and the variables are the theta 2, theta 3 and theta 4, and these two scalar equation or the loop closure equation in the scalar form is builds the relationship between the kinematic parameters. And as I mentioned in kinematics, there are two problems. When input is given, you have to find out the motion of others, or in order to get the desired input, in order to get the desired output, that means output is given, what could be the input? That means whatever may be the problem, whether the your input motion is given, find out the output, or in order to get the desired output motion, you have to find out input. Whatever may be the case, at any particular time instant, input is given. Say, first case input is given. If input is given means in this case crank is the input, then theta 2 is given. Then how many unknowns you have?
2.
So how many equations?
2.
You can easily solve and find out the theta 3 and theta 4. Clear? But my point, two equations, two unknown, because at any particular time instant, one thing you have to give, input has to be given because it is given by the motor. Clear? Or if you like to solve the reverse problem, that means for a desired output, that means here theta 4 is output. If your problem is I like to get this amount of theta 4, what could be my theta 2? Then again, reverse problem also output theta 4 is given to you, unknown is theta 2 and theta 3. Clear? So whether it will be the forward problem or reverse problem, any of the problem, one parameter at a particular time instance given, remaining two motion parameter you have to find out. So that is your two equation, two unknowns. Now question is this equation, the equation I have shown, this two scalar equation, whether it is a linear equation or non-linear equation.
Linear equation.
Don't tell blindly.
Non-linear.
Non-linear.
Again, the follow-up question is why?
The sine and cos are not linear function.
Sine and cos may not be the linear, but always you have to tell this is the equation for the thetas, brother. That means the angular position, no? What is theta? Physically now tell me, what is theta? Theta is angular position with respect to the reference frame. Now we come into the physics, not in mathematics. So thetas are the angular positions. Now it is the equation of angular position, and angular position is here. Angular position is within the cosine or sine, as it is the equation of thetas, and it is within the sine or cosine, and sine and cosine is non-linear, so that is these two equations of the non-linear equation. Now how to solve this equation? I think you know from your class 10 to 10, 11, 12 level trigonometry. Okay, so your job is to solve this two equation. When theta 2 is given, that means theta 2 is known, you have to find out theta 3 and theta 4. I think you can easily solve these two equation by using the concept of trigonometry. Now CR, please take the attendance, and if you have any attendance means screenshot, and if you have any doubt, anyone have any doubt, please tell me. Today's my part is over. You find out the solution. Next class, I'll see. It is the assignment. Okay.
Sir, hello, sir. Sir,
Sir,
left top corner, sir, why have you written minus R4 and minus R1?
you don't see this one because I have taken. You don't see this one. The way I have mentioned, you don't see all these things. So I have copied. I will give the fresh one. I have not got time to write this one. That is why I had taken a scan. But by mistake, I have put a full page actually. Okay. Don't see this one. Only see this one. This equation. Put the expression. You do derivation. Ultimately, you will get this one. Okay. Clear? That part you do it in your copy and show me next class. If you will not found, then I will once again retype properly and I will show you. But better you do it.
Okay, sir. Okay.
Okay. The upper portion is the wrong one. I have taken my class note, but that I changed actually the way to represent. In many ways you can represent. This way, this the book has been represented. That is why I have done. But now I have changed the way of representation, and accordingly, but ultimate result will remain same. Ultimately, you will get the same thing. Okay. Do you have any doubt? Anyone have any doubt?
Sir,
No, sir.
Hmm.
sir, the
No, sir.
theta must be measured from the tail to the the head pointing towards the head,
Yes.
or should it be measured from the head? Like in this theta 3 and theta 4 are being taken from the head.
No, no, I have not taken from the head. I have taken from this one only. Theta 4 dash, that is a symbol I have used different because the already had used this symbol here. This is not measure. This is the angle, simply angle. But here the angle for the vector.
Okay, sir.
Today, what you will do, the thing I like to mention here, theta, the whenever you put here, no vector, that means R4.
Yes, sir.
Of this theta. I am talking about this theta. Okay, theta 4 bars. Clear?
Yes, sir. Yes, sir.
Now, as suppose in a given problem, this angle is given, not this angle. Say, let us say this angle is given as a 60 degree. Clear? Let us
Yes,
say
sir.
in problem, this angle is given as 60 degree. This particular angle in your problem statement given 60 degree. Then what you will write? Theta. What will be the theta 4 now? Tell me theta. Sorry, theta 4 bar. What could be the theta 4 bar?
60 degree plus 180.
180 plus 60.
Yes,
180
sir.
plus 60. That will put
Yes,
it
sir.
here. That will
Okay,
put it
okay,
here.
okay.
Forget about other things.
Okay, sir. Okay, got it.
Yeah. Similarly for theta 1 also, you always measure angle with respect to this. This is the given angle. Forget about the given one.
Okay, sir.
Sir,
Tell me.
sir, it is a degree of freedom mechanism. So, sir, it should have only one variable.
No, no. One variable. You can completely define this mechanism motion by one variable. Clear? That is theta 2, where active joint is there. But other passive joint is also the angle is varying. Angle is varying, but it is dependent on theta 2. Clear?
Yes,
You
sir.
might have number of variable. Who told you that there will be only single variable? There will be single independent variable. Then only it is 1 degrees of freedom. You forgot that the degrees of freedom definition. Degrees of freedom definition says minimum or number of independent variable required. A system might have a number of variables, but independent variable is one, other are the dependent on that particular independent variable. Clear?
Yes, sir.
Here theta 2 is independent variable. Theta 3, theta 4 are variable, but it depends on theta 2. So that is why they are dependent variable. And degrees of freedom definition says number of independent variable required. And here number of independent variable required is only theta 2.
Yes, sir.
Sir, sir.
Tell me.
So there, so here is three variables and five constants. Because
Here
theta
is the
two.
three motion variable, three variables.
Okay, sir.
Other are the geometric parameter. Link length is the geometric parameter. It is the geometry, no?
So if there is three variables, but we have two equations.
Three variable, but whenever you like to find out that you see physically. If I give you that this is the slide diagram mechanism, find out the motion. Arey bhai, you have to tell what is the input, then only I'll tell the other motion, no? Got my
Okay, sir.
point?
So theta two is given.
If you will not give any input,
Okay, sir. So theta two is given, and theta three and theta four we have to.
theta either given
measure.
or you have to measure. Theta has
Okay.
to be given or it has to be measured, because theta 2 is the dependent is your independent variable. No, theta 2 is an independent variable that is provided by the motor, say in this case actuator. Once you rotate the actuator, you can see the theta 2 is varying, and that you can easily measure. And at any particular time instant, if you like to find out what is your output, without knowing input, how will find out the output? So you have to know the input, you have to measure that output, and that you have to measure the input. That input has to be fed to that particular equation. Then equation will tell you the output. Clear?
Yes, sir.
Thank you,
Sir, to
sir.
solve a system of equations, sir,
Tell me.
sir, to solve a system of equation, number of variables should be equal to number of independent variables.
Number of
Number of independent variables should be equal to number of equations.
who told you?
Sir, if theta 3 can be interpreted in the form expressed in terms of theta 2, then we don't require any independent equations for that.
Once again, tell me.
Sir, I am saying that theta 3 can be expressed in the form of theta 2.
Theta 3 can be, you can represent by the in form of theta 2. So that is your object, that is your job here actually. That I have not done. That is why I mentioned you solve find out the theta 3 and theta 4. You have to find out theta 3 and theta 4 in terms of theta 2 only. So I left that particular job for you, no, that you have to solve this equation, meaning is you have to find out theta 3 in terms of theta 2, also find out theta 4 in terms of theta 2, because theta 2 is always given to the independent variable. That is for after solving these two equations, you can write theta 3 in terms of theta 2 and theta 4 in terms of theta 2. That problem is given to you to solve in a home.
Okay,
Clear?
sir. Yes, sir.
Okay, so problem is clear. This is the equation, these two equation. Now you have to find out theta 3 in terms of theta 2. Only theta 2. There should not be any theta 4. Because theta 4 is again dependent. So you find out expression of theta 3 in terms of independent variable, that means theta 2. Similarly, you find out theta 4 in terms of theta 2 only, along with the other constant parameter. So this is your home task. Clear? Your home task is to form this equation. Theta 2 is known. You have to find out theta 3 in terms of theta 2, and also you have to find out theta 4 in terms of theta 2 only. Clear? So that is called the solution of this two equation, that where unknowns are theta 3 and theta 4. Got my point?
Yes, sir.
Okay, have you taken your attendance?
Sir, attendance is taken via the Google Forms. Or who has
Okay, okay.
taken it?
Okay. Now, one thing, another thing, the same way you can represent the slider mechanism. Now, this equation, I will do all this thing, but I just tell you this is the position equation. Now, if you do the time derivative of this one, because here theta 2, theta 3, theta 1, theta 4, these three are the variable. I mean, variable means vary with respect to time. Now, if you time differentiate it, you will get the displacement is velocity equation. Clear? These two scalar equation, both sides you differentiate with respect to time, then you will get the velocity equation, because dt of cos theta 2 will be your minus sine theta 2 into theta 2 dot. What is theta 2 dot? Theta 2 dot is omega 2. Clear? If you can differentiate both sides with respect to t, you will here differentiate both equation, you differentiate with respect to t, then you will get the velocity equation. Again, differentiate it with respect to time, you will get the acceleration equation. So if you understood the loop closure equation in a vector form, then in scalar form, after that is the mechanical thing. So you have to do time derivative, carry out the time derivative, apply the fundamentals of differential calculus, and you can find out the velocity equation, acceleration equation. Clear? Same thing can be used for your slider mechanism. Slider mechanism also same type of, you can find out that position equation like this way, then time differentiated, velocity equation, again time differentiated, acceleration equation. Once you get this acceleration equation, then you can easily find out the how much force is required, because you know the Newton's second law, force equal to mass into acceleration. Okay. So acceleration is required to find out the how much force or how much torque is required. Clear? So that is why once you solve the kinematics, then once you go up to the your what is called acceleration, then that acceleration will be input in your Newton's second law, and you find out how much force or how much torque is required to get that particular acceleration. Clear? So that part, the dynamics part, will be covered by Professor Haldar. Professor Vishwajit Haldar will cover either tomorrow or the next week. But fundamentals is this one. You remember, first you have to go up to the acceleration equation, then that acceleration equation will be input for your kinetic analysis, also called dynamic analysis. Clear?
Okay, sir. Okay.
Okay, thank you.
Thank you, sir.
Thank you, sir.
Okay, bye.
Thank you, sir.